Hey everyone! Today in this video we are going to learn about the direction of flow of current. This is a continuation of the last video, so if you haven't watched the last video, please go through the series lectures of ABCDs of electricity. Let's continue. So in most practical applications of electricity, we have seen an involvement of a flow of charge from one point to another. So if there's a point A and there's a point B, and if there is a charged particle at point A, and if the charged particle or the charge itself flows from point A to point B, then what do we call it? The flow of charge from one point to another is referred to as electric current, or we simply call it as current. Now, what determines the flow of charge? How will you understand from which direction to which direction the charge will flow? So when there are two bodies means say there are just two materials at different temperatures. So the material A in this figure is at a higher temperature, the material B is at a lower temperature. And suppose these two bodies are brought in contact with the help of a metallic wire or any kind of conductor. What will happen immediately? Heat starts flowing from the body at a higher temperature to the body at a lower temperature, and this flow of heat is irrespective of the quantity of heat contained by the two bodies. So even if you do not know what is the quantity of heat, how many calories are there in body A or how many calories are there in body B, even if you do not know, if you just have the information that body A contains a higher temperature and body B contains a lower temperature, you will immediately be able to say that the heat transfer is from body A to body B. This is the nature of heat. So, we can easily say that it is a temperature difference and not the quantity of heat that helps us to determine the direction of flow of heat. Now, previously we were talking about electricity, current, charge. Now we are talking about heat. Why? Because the flow of charge or flow of electricity is quite similar to the flow of heat. And flow of heat is something that we can see in our daily lives. For example, if we just touch a hotter object with a colder object, so we can easily immediately see that the hotter object starts getting cooler and the cold object starts gaining temperature and it gets hotter as they are in contact. Similarly, there is one more very common example that we can take from our day-to-day lives, that is water. Water also flows from a higher level to a lower level irrespective of the quantity or volume of water contained at two levels. So if we see there are two beakers, this beaker is at a higher level and this beaker, the level of the water in this beaker is lower. Now we do not know what are the quantities of water in these two beakers. Maybe the first beaker also has 1 liter of water, the second beaker also has 1 liter of water. But since the first beaker is narrower, so the height of the water seems to be greater. And since the second beaker is wider, the height seems to be lower. So the levels are different. Doesn't matter what is the amount. So for two different beakers with different levels of water, if we connect the beakers with the help of a pipe, what will happen? There will be a transfer of water from the higher level to the lower level, and you can immediately see this if you can build a setup like this. Now in the same way, the positive charge flows from a body at a higher potential to the body at a lower potential. So we cannot see the charges inside a material, but similarly, like heat and water, we can know that the positive charge always flows from the body at a higher potential to the body at a lower potential. But the negative charge flows from a body at lower potential to a body at higher potential. The tendency of the negative charge is just the opposite. Now, here I have shown a setup. You can see that this is a metallic body whose name is A. It has plus charge and it is at a higher potential. This is B. It has minus charge and it is at a lower potential. These two bodies are conducted or are connected by a conductor. This is connecting wire. So we can see positive charge is flowing from the higher potential to lower potential. These two are insulated stands. You can ignore this. These are just stands to keep the metallic bodies. Now, in the second setup, it is not the second setup, it is actually the same setup, but what we are showing in this setup is the flow of negative charges. So this is again higher potential, this is lower potential, and the negative charges are flowing in this direction, that is from B to A. That is from the lower potential to the higher potential. Remember, the flow of charge only takes place when the two bodies are connected by connecting wires. So the flow of charge continues until and unless the potential of the two bodies become equal. So it's not that the charges will flow forever. It will stop. But when will it stop? When the potential difference between two bodies becomes zero. So there's no difference between two bodies. And when will it become so? When the potential of these two bodies will be equal. Now, let's come to the main question. What is the direction of flow of electric current? Till now, we were talking about charges, but what is the direction of electric current? So actually, when electricity was discovered, when electricity was known to human beings for the first time, at that time, electrons, protons were not known. So it was found that there were only two kinds of electricity, positive electricity and negative electricity. People knew only this much. They did not know about the subatomic particles and all those at that time. So what happened? At that time, the direction of flow of positive charge was taken as the direction of flow of current. So then onwards, even now as a convention, the direction of current is taken as the direction of flow of positive charge. So this is the direction of flow of positive charge, A to B, higher potential to lower potential. So even now, although we know that there are electrons, protons, electrons are actually those particles which help in the flow of current. Protons do not move from their position, but still it is universally agreed as a convention that we will take the direction of current from higher potential to lower potential, from plus to minus. Now we know that the conductors such as copper, metals conduct electricity due to the movements of electrons. Actually, these negatively charged particles help in the flow of current, not the positively charged particles. But we say, we consider the flow of current in an ordinary conductor such as copper wire or any other metals. The direction of current is taken as opposite to the direction of flow of electrons. So if current flows from A to B, then electrons will flow from B to A. The directions are taken as opposite, but actually current is nothing. The charged particles, that is the negatively charged particles, flow from B to A, and that's why current is produced, but still the direction of current is taken mathematically from A to B due to the convention. So if in a conductor the electrons travel from B to A, then the current is said to flow from, it is said to flow from A to B. That's all. This is the current flow and the electron flow direction. Okay, so what did we learn today? If there are two bodies, one at higher potential, one at lower potential, the electric current is said to flow from higher potential to lower potential. The positive charges flows from higher potential to lower potential, but actually the positive charges do not flow. It is just conventionally said that the current flows from plus to minus. On the contrary, if there are two bodies, one at higher potential and one at lower potential, the electrons, that is the negative charge, flows from lower potential to higher potential. And who are the negative charge? They are the electron. So just like this, if you want to get the flow of videos from my direction to your directions, do like the channel, do subscribe the channel and share it with your friends. See you soon on the next video.